Hi guys, welcome to this video lecture. This is Dr. Moorthy, working as Assistant Professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So this is a lecture series of engineering mechanics, and in this video we are going to discuss about a topic called product of inertia. In this previous lecture video, we have discussed about moment of inertia and parallel axis theorem and perpendicular axis theorem. Likewise, here we have a product of inertia. So the product of inertia is the multiplication of moment of inertia in horizontal axis and the moment of inertia in the y-axis. So we can get the product of inertia. So the product of inertia Ixy and quantifies how an area is distributed with respect to two perpendicular axes, right? So we can get the multiplication of x and y coordinates so that we can get the product moment of inertia. So another one, before into the product of inertia, we should know some basic the concept with the product of inertia, where when the product of inertia is to be zero, the conditions are it is the object or the section is to be symmetric about x-axis or symmetric about y-axis or symmetric about both horizontal and y-axis. Another one, shapes like rectangle, circle aligned with the axis. So where we have the moment of or cement, that is moment of inertia is to be lying in the midpoint of the each section, and the when the product of inertia that is called Ixy is the integration of x, y and with respect to the area of the particular section. So where the moment of inertia is positive or negative based on the quadrant and it is the location. So the moment of inertia, the product of inertia is positive when it is lying in the first and third quadrants. As like seen in the previous slide, the moment of inertia in the first quadrant and then fourth quadrant, we get the positive where in the first quadrant both x and y are positive. Similarly, in the third quadrant, x and y are negative. So that the multiplication of moment of inertia with the horizontal and y-axis, we can get the positive as like in the first quadrant, and in the second quadrant the x is minus and then y is positive, and multiplication of the moment of inertia of about these two axes, we can get the moment of or the product of inertia in the negative. And then similarly in the fourth quadrant, the x is positive and then y is negative, so that the product of inertia is negative as like in the second quadrant. So the conclusion is the product moment of inertia is positive when it is lying in the first quadrant and then third quadrant, whereas the product moment of inertia is negative if it is present in the second and fourth quadrant. So as it is mentioned here, the first and third quadrant, the product moment of inertia is positive, and in the in the second and fourth quadrant, the product moment of inertia is negative. And its significance of product moment of inertia, it is used to determining principal axis and important unsymmetrical bending, helps to understand the coupling between both horizontal and y-axis, and is used to find the stability and vibration analysis of any object, and what is the necessary to study the product of inertia is to determine principal moment and predict twisting and bending behavior of object, and to analyze the unsymmetrical structure, and what is the product of inertia and moment of inertia, and it's to be improve safety and design efficiency based on to find or analyze the stability of the object with respect to the principal axis, either horizontal and vertical axis. And some basic engineering applications like used in torsion, bending and shear stress analysis application, and for civil and mechanical design application like vehicle stability is to so the product inertia is to identify the vehicle stability, earthquake resistant structure and aeronautical design, and aeronautical design, and some assessment wide like the product of inertia of symmetrical section is always zero, as we discussed in the previous slides, and the product of inertia is given by the integration of xy into the area of the concerned section. So thank you.